All right, so in lesson 3 of Learning Guide 3, we're not only now looking at the derivatives of sine and cosine, we're now moving on to tan, cotangent, cosecant, and so on. So these are all on your formula sheet, which is really nice. I'm just going to write them down quickly for you. Notice how we're using a u here. So you still may have a composite function. You may need to take that extra derivative. So we've got sine is going to become cosine. Cos, again, we've already talked about these ones already. Tangent, the derivative is secant squared u du dx. Cosecant is kind of a longer one. Negative cosecant u cotangent u du dx, a little bit messier. The derivative of secant actually includes itself and tan. And then the last one I've got our cotangent. It's going to be negative cosecant squared u du dx. Okay, so nothing that you're not going to already see on your formula sheet. Now, all we're going to do is basically practice using these in this lesson. So take a look at number 1. We've got a y equals 3 times tan 2x. Now remember I mentioned in the last lesson, if you have a coefficient at the beginning, you don't need to worry about it because technically it's uv prime, but plus vu prime. However, that derivative is always going to be 0. So the derivative of this guy, I can keep that coefficient there. I've got tan of 2x. Now remember, this is the chain rule, right? I've got a composite function there, and therefore I need to take the derivative of tan first. Remember, outside in. Well, the derivative of tan is secant squared. I keep the inside as it was, and then I multiply by the derivative of that inside. Now I can simplify. So I've got a 3 and a 2. So I can say 6 secant squared 2x. And that would be our first derivative. All right, let's take a look at number 2. Again, please, guys, I encourage you, especially in this unit, pause, try, pause, try, pause, try. All right, so y prime, I've got my 12 is going to stay right where it is. The derivative of secant, remember, includes itself. So it's going to be secant times 1 over 4x, then tan times 1 over 4x, and then the derivative of 1 over 4x would just be 1/4. Simplify that. 12 times a quarter is going to be 3. And then the rest of it, we need to just leave exactly how it was. Okay. Next one, number 3. I've got tan squared cos x. Again, a function in a function. Now this squared, what I always like to do is move it to the outside, so we can actually see what it applies to. That tan is being squared, which means the whole thing is being squared. So if I'm taking the derivative of this in the chain rule, I need to deal with that 2 first. Leave everything inside exactly how it was. Okay, and then start to take the derivative of the inside. Now again, we want to start off with tan, which, remember, the derivative of tan is secant squared of cos x, okay, because I'm leaving that exactly how it is. And then I need to multiply by the derivative of cos x, which is negative sine x. So this is a big one. Now you want to go through and see, you know, what can you simplify, if anything. Well, a lot of these are just separate functions. The only thing that we can really do here is move that negative to be with the 2. So I would just say negative 2 tan of cos x times secant squared of cos x times sine of x. Okay? Kind of a big, long, crazy one. All right, now I'm going to run out of room, so I'm going to erase this, but I want you guys to take a look at number 4. Now, you've got a function inside of a fraction, and in particular, it's in the denominator, which is kind of yucky. So I'm going to move everything, first of all, over here, and then we're going to rewrite it to see if we can simplify it a little bit, make it look nicer. Now remember that flower power rule that you guys learned way back in grade 10 or 10C, where this is my power and this is my root. And remember that the power over the root is my fraction. So this I can rewrite a lot nicer as 3 over 2. And then I just need to remember that that's a negative because it's in our denominator. So see how much nicer that is rather than working with it in a fraction. So I encourage you to do that. Now again, this is the chain rule. So first thing we need to deal with outside in is going to be that negative 3 over 2. Leave everything inside how it was. Now remember, we subtract 1 from my exponent. So basically, we're minusing 1, which could be like 2 over 2. So this would become negative 5 over 2. Then we want to multiply by the derivative now of the inside. So remember, the derivative of secant involves itself and tan. Okay, then I've got tan, and notice how I haven't changed that function on the inside. But now that I've done the derivative of secant, I now need to take the derivative of the inside, which is just going to be 2. And now just comes simplifying. So basically you want to identify, well, what can I simplify together? Well, I've got this guy and I've got this guy. So that's nice. I've got negative 3 over 2 times 2, which is just going to become negative 3. Then I'm left with secant 2x minus 1 to the power of negative 5 over 2. Then I've got secant 2x minus 1, and we're multiplying that by tan of 2x minus 1. Okay. Now, do you see anything, like we've kind of simplified all the easy stuff, but now when you take a look, is there anything that we could also simplify together, do you guys think? Anything you see? Well, hopefully you see this and this are exactly the same, right? This is to the power of positive 1. That's to the power of negative 5 over 2. And if you remember, when we multiply, we add our exponents. So this would be like negative 5 over 2 plus 1. So I would have my negative 3. This can be simplified. Now, negative 5 over 2 plus 1 is, again, like 2 over 2. So that's going to take me to 3 over 2. And then I've got my tan of 2x minus 1. Okay? So we could leave it like that, and that would be a great final answer. Or we can make it look kind of like the original question, which is sometimes what your questions do. And this, because it's to the power of a negative, obviously is going to move to the bottom. So I've got my negative 3 tan 2x minus 1, all divided by, now it's a negative 3 over 2. So remember, that's the square root then of secant 2x minus 1, all being cubed. Okay, and that would be a nice final answer there. So that's a pretty long, intensive one. All right, let's move on to number 5. Now these questions, again, you've seen them before. Find the equation of the tangent to the function y equals 4 tan squared x at that given point. So right away when it says find the equation of the tangent, you want to think y equals mx plus b. Remember, we already have an x in this case. We kind of already have a y. All we have to do is solve for it, right? And we do need to find an m and a b. M, nice and easy, remember, is our derivative. So if I've got y equals 4, and I'm just going to move that squared out, just because that's what I like to do. And now we're going to take the derivative of this. So that 4 stays where it is, that 2 is going to come down, so it's just going to become 8 tan of x, and then we're multiplying by the derivative of tan, which is secant squared. Now, if I want to take a look at my secant squared, if I want to actually find my slope, I know that x is equal to this, and that does involve the unit circle, right? I'm going to need to use it. Now we know that secant isn't really on the unit circle, right? Tan is sine over cos, and secant is 1 over cos. So I can take my tan of pi over 4, and I can multiply that. And even, guys, I'm just kind of taking a shortcut because we know tan is sine over cos, and we've already done this question, which is pi over 4. We know that that's going to be root 2 over 2 divided by root 2 over 2. This one is going to be 1 over cos pi over 4 squared. Okay? So if I'm actually looking for my slope here when x is equal to pi over 4, I've got 8 times 1, remember we've done that before, times 1 over, now cos of pi over 4, we already said root 2 over 2, and that's going to be squared. Okay, this is now going to become 8 times 1 over 2 over 4, should look kind of familiar. This would simplify to 16, because it's going to be 8 times 2. Now this is equal to our slope, which is cool because that is something that we need to answer our final question. We have our x already, but we were not given the y. So like I mentioned at the beginning, the y we can solve for by knowing what x is. So I'll just do this in a different color. So find y when x is equal to pi over 4. So let's do that. Y equals 4 times tan of pi over 4 squared. Now we've done this heaps of times now. Tan of pi over 4, we should all know now is 1. 1 squared is 1, so 4 times 1 is going to be 4. So now we've got our y, we've got our m, and we've got our x. Now we can finally solve for our b value. So let's plug it all in. Our y we said is equal to 4. Our slope was equal to 16. X was equal to pi over 4. And b is what we're solving for. Now we can simplify. 4 equals, well, 16 pi over 4 is just going to simplify to 4 pi plus b. And remember here, we can just simply subtract our 4 pi from both sides, and that's going to be equal to our b value. You don't need to simplify it. In fact, you can't. So we're going to leave it just like that. So our final answer, remember, needs to be in the form y equals mx plus b. Y and x stay exactly as they are. M we figured out to be 16 times x plus b, which is 4 minus 4 pi. You can leave it like that, guys. Or, remember I was saying that other question that we did in the last lesson, you can also set it equal to 0, which would just be negative y plus 4 minus 4 pi. And again, in your textbook, they like to use that method there. Okay, so there are some practice questions that you guys can do on what we've just discussed. I really encourage you to do that. But if you actually flip over, we have 2 other questions that we thought that we would throw in here just for some really good extra practice. And this is what's involving implicit differentiation. Now, if you don't remember what that is, that's okay. Just remember it for the test. But implicit differentiation is basically when I have a y and an x in my function, in my equation. So I've got like kind of 2 functions. And remember, what is the derivative of y? Well, it's either y prime or dy dx. And in these cases, we actually have to take the derivative of y and include it in our function and then actually solve for it. Okay, so if you don't remember what I'm talking about, take a look back at the last lesson in Learning Guide 2, which is where we did quite a bit of it. So we're doing the same thing, but now obviously we're just throwing in some trig. All right, so let's take the derivative of this. Tan x, the derivative of that is going to be secant squared x plus the derivative of secant, remember, is secant y tan y. We're just going to leave that as it is. But what do I need to include? I have got a y. I need to take the derivative of y, which is dy dx. Okay? Minus y. So again, the derivative of y is again going to be dy dx, and that's going to be equal to our 0. All right. So now what we need to do is isolate our dy dx, because remember, that is the form that our answer needs to be in. So I'm going to move everything to the other side. So I've got my secant y tan y times dy dx minus dy dx. And we're going to move that secant over, so it's going to become a negative. And now we want to factor out our dy dx. So I'm left with secant y tan y minus 1 is equal to negative secant squared x. I want to divide now both sides by secant tan y minus 1. So our dy dx is going to be negative secant squared x over secant y tan y minus 1. And that would be our final answer there. So again, remember those steps in order to solve for that dy dx. Okay? So now that you've got a good understanding of that one, really, I encourage you, please pause it, try the next one yourselves. You can do it while I'm erasing. And then just come back and fast forward. All right, so I've got y squared minus cosecant xy is equal to 0. Let's take the derivative of this using our implicit differentiation. So first I've got 2y dy dx. Remember, guys, please, every time you have a y in there, you need to include dy dx. Minus the derivative of cosecant is cotangent xy, cosecant xy, oops, sorry. And then we need to take the derivative of the inside, which is xy. So this is like our u and our v. So remember, uv prime plus vu prime. So let's take a look here. Our u times our v, so that's going to be x and dy dx, plus the derivative of u is just 1. So we're going to be left with y, and that's going to be equal to 0. So that's the first big step. Next one is obviously simplifying. Now remember, guys, that we need dy dx to be all by itself. Well, right now it's stuck in here. So what we're actually going to have to do, which is kind of a pain, is expand and then get it out of there. Because right now there's no way I can just kind of get it away from all those other terms. Okay, so I'm actually going to need to take this and multiply it by everything in the bracket. So this next part is going to look really ugly. Okay, so I've got my x dy dx, cotangent xy, cosecant xy, plus my y, cotangent xy, cosecant xy is equal to 0. Brody. All right. Now I've got two terms that have my dy dx in it. So obviously we want to move everything over to the other side. Now I'm going to kind of skip a little bit because we can obviously determine that we're going to be factoring that out. So I'm going to be left with my 2y minus x cotangent xy cosecant xy, and then I'm moving this guy over, right? Minus y cotangent xy cosecant xy. It's like trig overload. All right, now the last thing that we need to do is obviously divide. So dy dx is going to be equal to negative y cotangent xy cosecant xy over 2y minus x cotangent xy cosecant xy. Isn't that fun? All right, so I can see that I may have made a mistake on one of my signs here. Sorry, guys. Right up here, sorry, hopefully you guys caught this. I just noticed, so I'm not going to redo the whole podcast, but I've noticed here that right away I should have had, because this is a minus, I should have had a plus here. So sorry about that. So this should be a plus, this should be a plus, and therefore this should be a plus. So I'm really hoping that didn't screw you up too badly. Because we had a negative and a negative, remember the cosecant, if you take a look at that derivative, it's a negative. Negative of a negative is obviously a positive. So I'm really sorry about that. As I looked at my answer, I'm like, ooh, wait, it didn't match up. But everything else is good, and everything else should be exactly the same. So if you have any questions with that one, just come to the help desk or watch it again, and now you know that I've kind of made that mistake already, so just watch it again, or just make sure that you can do it on your own. All right, guys, good luck. That's the end of this learning guide.